I wanted to welcome Mark Fume for accepting to present today. Mark is a co-founder and CEO of the DNAstack, a Toronto-based genomics software company with a mandate of making genomics and clinical bioinformatics globally accessible and useful. So welcome, please introduce yourself more. But thank you so much. We really appreciate you being here. Go ahead.
Of course, thank you so much for having me. I hope you can see my screen. Is that right, Natalia?
Yes, we can do. We can.
Oh, okay, wonderful. Okay, well, thank you so much for having us. Today I'm going to tell you a little bit about what we've been doing at DNAstack to to bring forward a future that is aligned with open standards and federated. So here's our agenda for today. I'll talk through the problem as we see it and the solutions that we've been working on. In the context of some case studies, we'll show you a demonstration of some of the software that we're using, and of course, happy to answer any questions. I would really appreciate it if you interrupt me and ask questions as you have them. Of course, we'll have some time for questions at the end, but this is, hopefully to your benefit, and I'd welcome you to ask any questions that you have. I'll start by applauding your goals as we understand them. We think it's really critical to empower pan-continental network and enhance data science capacity throughout African countries and to sort of create a future where we can more dynamically and collaboratively work together to drive new discoveries in genomics and health. In many ways, what you're doing is why we built this. We want to build a software platform in order to democratize access to data and infrastructure and really empower communities to own and connect on their own terms. So I think what you'll see from the rest of the conversation today is trying to be really thoughtful about empowering local data custodians to participate in a sort of global or international collaboration in compliance with open standards, but really on your own terms without the need to give up sovereignty and control over data. So the problem, as we've been seeing it for the last, say, decades, and of course is not just how we see it, but how the global community is recognizing this opportunity to drive discoveries from genomics and health data across exponentially growing volumes of it. Yet far too often we find when we speak to data scientists, they don't have access to larger, diverse enough data to make their discoveries. And so potentially life-saving data end up being siloed by device, by database, by organization, by province, by state, by county, by country, by continent, and by cloud. And so this traditional idea of creating a centrally managed database, we think is unscalable. And so instead of thinking about creating a centralized database, we would like to think of the future as being federated, where just like the internet as we know and use today, we envision a future where data are unsiloed across these traditional boundaries and connected over continental and global networks. This internet will democratize access to data, knowledge, and services across networks in real time. So we want to move away from the image on the left where data custodians are asked to centrally upload their data to a platform that allows researchers to ask their questions of the data in one place, moving towards a future that's depicted on the right, where data custodians retain local sovereignty and control of their data, and through the power of interoperable standards and modern software, we can move researchers' questions to the data. Answers are computed locally, and only aggregative information is communicated back. So with data federation, it allows us to unsilo the data while simultaneously deliver benefits of sovereignty, security, cost efficiency, privacy preservation, scalability, and freedom. So when studying this problem, we recognize that there are precedents for creating federated networks, specifically looking at the internet and telecommunications. And in studying those examples alone, it's not hard to reason that what's important um, to power the scalability and connectivity of those networks is an underlying fabric built upon open standards. So the most successful federated networks, like the internet and telecommunications, are built upon standards that enable interoperability, scalability, and global collaboration. And so we and others, including many of you, I think have done a wonderful job bringing together this global community in the Global Alliance for Genomics and Health, or GA4GH, excuse me, which has become the de facto international standards body for defining these open standards. And the GA4GH has come a long way, and in the 10 years it has been around, and there are many mature standards that we think are production ready and ready to be built into products that allow this internet to be built. So it's with that context that I'll introduce Omics AI, which is sort of enterprise grade implementation of GA4GH standards that enables us and our partners to work together to build federated networks for genomics and health research that allows for data to be more scalably discovered, accessed, and consumed through analytics. So Omics AI is fully compliant with many standards across the Global Alliance for Genomics and Health, including predominantly standards for data discovery, data analysis, and data access. We have a sort of open source technical blueprint. Um, we built it in the context of the Canadian environment, as we're funded by the Canadian government to create a sort of national data infrastructure. But the purpose of this blueprint was to sort of share our thoughts and our architecture on how to build GA4GH compliant data infrastructure. And if you're interested in reading that blueprint, it'll be published actually on February 6th. But if you're interested in reading that in advance, please reach out to us. Maybe I see Maggie Clark's on the call. If you can just drop Maggie a note in your interest in reading that blueprint, we'd be happy to share it with you. So Omics AI is a three-part software suite. The first is called Publisher, and the idea behind Publisher is to give you an environment to govern access to your data. The second component is called Explorer. That's sort of the federated hub that allows researchers to be able to discover, request access, and begin querying your data. And Workbench is a system for secondary and tertiary analysis, following many of the data analysis standards of the GA4GH. We were very sort of purposefully building Omics AI to try to maximize the reach and interoperability of the platform. And so it is multi-instrument in that it can work with any sequencing data or any data that can be represented as a file or a table. So many of our collaborators ask, can we bring in imaging data or EHR data? The answer is yes, as long as you can represent those data as a file or a table. We operate across multiple cloud platforms, specifically Azure, AWS, and Google Cloud, in any region that they support. We do have on-premise installation, although it takes a little bit more work to do an on-prem deployment. And we operate across many different regions. We're active pretty much globally at this point. So I want to talk about how we're taking Omics AI and deploying it in the context of different case studies across rare disease, infectious disease, neuroscience, and oncology, and then we'll round out the presentation with a demonstration. So we're really fortunate to have the opportunity to collaborate with many partners who are using the platform to grow internationally collaborative research efforts across multiple sectors. So, with advocacy groups like Autism Speaks and Michael J. Fox Foundation and Target ALS, we're working with them to increase the impact of the great research data that they are funding. We work with hospitals like Hospital for Sick Children's and Children's Mercies and Radboud. We work with sequencing providers like PacBio, pharmaceutical companies like Roche, government agencies like the Department of Research and National Defense in Canada, research funders like Genome Canada, and international consortia like IPCHIP, which is actually a driver project for the GA4GH. So thematically, what those partners are using the platform to do is to build and grow federated networks in specialty specific disease areas. And so what we provide is this sort of ability to create your own um, specifically your custom branded federated network. You can see here Hi-Fi Solves and ASAP, for example, are branded with their own domain name, their logos, hero images, hero statements, and data sets. And the essence of the value that we provide is helping those data custodians increase the impact of the data that they control while simultaneously unifying the interface for delivering discoveries for researchers. So with the Michael J. Fox Foundation, we're working on a project called Aligning Science Across Parkinson's. This is unifying the data that is being generated across 40 different research teams worldwide, and providing a single mechanism through which they can request access and drive new insights. IPCHIP is the International Precision Child Health Partnership. It's bringing together 4 pediatric hospitals and Sick Kids, Boston Children's, Murdoch Children's Research Institute, and UCL London, again, to rapidly share data across these pediatric hospitals, focusing on early onset epilepsies for early diagnosis and treatment. Hi-Fi Solves is a global collaboration led in partnership with PacBio that's currently connecting 10 organizations worldwide who are doing long-read sequencing with ambitions to scale this year to connect over 30 organizations across the year, specifically looking at those hard to sequence, hard to analyze regions that are causal in rare and other genomic disorders. And this is going to be announced on February 6th, but we'll announce a new pan-Canadian national data infrastructure project looking to democratize access to this infrastructure across Canada. So those are some examples of how we're using Omics AI. And finally, I'll switch to a demonstration of the products. And maybe I'll just pause to see if anyone has any questions on the introduction right now. Okay. So the first software tool I'll show you is called Publisher. And Publisher is a tool for data custodians to connect, organize, protect, and share their data over GA4GH standards. The first step in the Publisher experience is to connect a data source. And so we've built data source connectors to popular object and relational databases like AWS, Google Cloud, Microsoft Azure, as well as MinIO for on-prem deployments. And then on the relational database side, we have connectors to Postgres, Trino, and BigQuery. So once you've connected your data source, we begin indexing the contents of those data sources into a master library. So this contains all of the data and tables that you've connected across all of the data sources. And the next step in the journey is to organize the contents of your libraries into what we call collections. So collections are essentially data sets that contain the subset of data that you'd like to share with the world. Here I'm showing you one data set that we've curated. It's called the Consortium of Long Read Sequencing Datasets, or COLORS. And colors has four tables that I'd like to share over these GA4GH standards. So a collection or a data set is described with a name and a rich text description, where inside of the description, you could also have links that link out to licenses or data sources or attribution policies, right? It's really flexible in terms of the metadata that you can attach to it. We also have support for tags that allow for us to group collections across um, different tags. The most important aspect of the publisher is this sharing tab, which allows us to turn on GA4GH compliant APIs with just a couple of clicks. And so here I'm saying that this collection should be discoverable on the Hi-Fi Solves network. It should be searchable, and we would like to allow the researchers to download. So here I've turned on search and I've turned on download. And when I turn on those APIs specifically, I'm turning on GA4GH Data Connect and GA4GH Data Repository Service Standards on top of this data set. Each of these services can be prescribed an access policy. And so it's possible for me to have made this particular access policy controlled access and the download, for example, registered access. And so each service is independently controlled. And in the case when we have prescribed a controlled access policy, I have the ability to manage who has access through an allow list, as well as the ability to solicit access requests from potentially interested researchers. So we've built in functionality to create a custom request form, where in this example, I'm just asking for an email address, but you could ask for, PubMed IDs or organization of affiliation, right? You can create a custom form that you would review in the process of making an access request decision. So those access requests stream into the publisher, and here I can see a list of individuals who've requested access through this policy, and you can see that one is pending review, and I can choose to either approve or deny. So it's built into the platform, this ability to control access and solicit access requests into specific data sets. Okay, so just as a reminder, we had published this data set onto a network called Hi-Fi Solves. But the last thing I wanted to show you before moving to the network is this new feature called questions. So we had worked for a long time on a protocol called Beacon. And the idea behind Beacon was to have this sort of go fish for genetic mutations where you would allow researchers to ask the question, have you observed this genetic mutation, this genetic variation or not? And it was sort of posed as a yes or no question. And the beauty of Beacon was that because the sort of information surface was very narrow and that we were only answering yes or no, that many organizations felt comfortable with sharing that level of information even publicly. And so we sort of took this idea with questions and expanded it to say that in general, data custodians are typically more willing to share aggregative information about their data set than they are about sharing row level information. And if we can create an experience and a feature that allows them to authorize these questions to be asked, that we would enable more discovery type questions to be asked earlier on in the data access request process. So here's a question that we've implemented. It's called allele frequency. And the idea is that given a position, a chromosomal position, we want to be able to return the aggregate of allele frequency across here, 1,300 samples. And so this is just showing how, as a data custodian, you could define a question to be asked, where the result of the question is de-identified, but we're still able to return aggregative statistics like allele frequency back. So I mean, this could be overwhelming for non-technical folks, but for the technical folks, the way that you define a question is through a parameterized SQL statement where the parameters become inputs. So here I've said that the two inputs to this particular question are position and chromosome, and the user is responsible for entering in values for those inputs when they ask their question. Okay, so finally, I'll switch over to Hi-Fi Solves, which is one of the networks we're growing in collaboration with PacBio and a large and growing consortium of data custodians connecting to the network. You can see here that all of these collections, these cards, represent individual data sets that have been connected to the network. Now, the beauty of the Explore platform, so this is the second product that you're looking at, is that it unifies the experience of discovering and requesting access to data sets. So I won't actually go through this whole process of requesting access, but I just want to illustrate that you can apply for access to all of these data sets through a very similar experience. Yet each of these data sets is still independently controlled by each of the data custodians that have connected their data sets to the network. So from a data custodian's perspective, you have ultimate control over who has access to your data. And from the researcher's perspective, it's really unified the process of requesting access. So here I'm going to click into a open access data set, the same one that I showed you within Publisher, to show you what the corresponding experience looks like for a researcher. So here I've clicked into a data set. It provides that same rich text description in the about, and here we see each one of those tables is clickable, and I can jump into any one of those tables. This particular one has aggregative information of all the variants that have been identified across this particular consortium. You can see here the allele frequency question is shown, and the experience is slightly different here where I have those same inputs on the left-hand side, and I have the ability to essentially ask this data set what alleles and what is their frequency at this particular genomic position. And just like the Beacon network, where we wanted to create a unified experience of asking questions across the network. So let's say multiple collections have implemented that same allele frequency question. We're providing that ability to ask a question across the network through these federated questions. So here I have the allele frequency federated questions, and instead of asking it of a single data set of the network, I have the ability to ask that same question across multiple collections. And in the coming weeks, this list will grow to about 10 different organizations. So you can think of this as sort of a federated nomad, where instead of calculating the allele frequency across a single centralized database, I'm dynamically computing the allele frequency across multiple nodes in the network. So here I see that this particular allele is with 13.5% frequency, and that is a response that has been computed as a function of allele frequency across multiple members of the network. So it's trying to take the idea of, say, a centralized database and still providing the ability to gain insights, but doing so in a way that is ultimately federated. Okay, the last thing I'd like to show you is Workbench. And so Workbench is secondary analysis and tertiary analysis workflow execution experience where we've worked in some cases directly with instrument providers like PacBio to author best practices secondary analysis pipelines that could run on multiple cloud platforms. So here, you can go to DNAstack.com, go to workflows, and you'll see a list of our curated workflows as well as badges to see where those workflows have been tested. You can click the run button and jump right into the experience of actually running the pipeline. So this particular pipeline has a bunch of inputs. I won't go through a complex workflow in this example. Instead, I'll just skip to something that's a little more simple. So here, I'm going to open just like a hello world example, where again, the sort of experience is just specifying inputs and choosing the engine that you'd like or environment that you'd like to run it in, and then submitting your workflow for execution. You might have seen similar examples of like Workbench. We're most compared to, say, DNA Nexus and Terra. On the Workbench side, the one sort of main difference between Workbench and other tools in the market is this experience of bringing your own engine and environment. And so with Workbench, we wanted you to have the ability to connect to local compute capacity on Amazon, on Google, on Microsoft, or on premise through the workflow execution standard. So once you've connected your engine running in your own environment, then Workbench essentially becomes a remote control that provides the instructions for how to do the computation, but all of the computation actually happens local to your own environment. And so we can see that that particular workflow has been kicked off and is running, and one that I've run yesterday has succeeded. Once the workflow is completed, you'll get a notification as well as a link back to the results. So finally, I'll just mention that for the data scientists that want more granular sort of programmatic control over their analysis, we do provide command line and Python library bindings that allow you to do interactive analysis through a sort of programmatic environment like Jupyter Notebook. So here's an example of how we can query the HiFi Solves network over the Data Connect standard from a Jupyter Notebook. And then I know some folks on your team are very interested in how you could run more sophisticated, sort of federated analytics. And for that, we have integrated Flower, where Flower is an open source federated learning framework that allows for us to stand up clients on top of workflow execution engines and to aggregate the learnings back to build AI and ML models. So if you can pose your federated learning experiment through the Flower framework, then that can ride alongside our Workbench platform and allow you to train across multiple nodes within your networks. So with that, I will stop and we'll see if we have any questions. Thanks.
Thank you, Mark. This was great. Thank you. Any questions, comments? Indresh, go ahead.
Great presentation, Mark. The question is how your platform is different than Terra, because I'm using Terra and in this one of the DSI Africa project, and in how so this is an open source project that we just register and use it. So how a new project can onboard, if you can walk through that, how that looks.
Yeah, good questions. Okay, so on the comparison, I would say that there's sort of three main differences. So the first difference is we provide the sort of publisher mechanism for GA4GHification of your data. So the ability to connect, organize, and share your data over GA4GH standards is sort of one difference where Terra mostly focuses on the analysis. The second is the bring your own engine feature of Workbench. So we can connect to any workflow execution service, whether it's running on Azure, AWS, Google Cloud, or on-prem. And then lastly is the federation feature, which allows us to drive insights across multiple collections of data without having to centralize them together. And then in terms of onboarding, I see Maggie's on the call. Maggie's done a phenomenal job onboarding. The way that it typically works is you would say, I need an installation of Publisher and Workbench in this particular region on AWS. And we'd spin up an instance of it. You would administrate control over it, and that would be one node in the network. We do the same thing for everyone who wants to collaborate. And typically it takes around 3 days to deploy a node and about 1 week per node to really onboard. Does that answer your questions?
Yeah, one more follow-up. So how the So how the licensing is just the AWS or the cloud cost, or there is an additional cost if we think about using this software in future projects?
Yeah, great question. So the cloud costs are all between you and the cloud provider. So there's no margins on top of cloud computing costs, so storage, networking, compute. There is a licensing fee for publisher that we can also discuss. For Workbench, there is no license, so you could use Workbench essentially for free on top of the kind of cloud expenses that you already incur as part of the compute.
All right, I'll touch base offline for further detail. Thank you.
Perfect. Nikki?
Thanks, Mark, for the great presentation and the demo. So just to follow up on that comment, so to the consortium that Awazi has been discussing this with Mark and DNAstack, and it's something that we would work out with them, a license, and then we'd try and get the different DSI projects on board so that each DSI project doesn't have to come on separately if they prefer to do it together, because then it comes on as one network. And yeah, so the reason we've been talking to DNAstack is we're finding that many of the DSI projects have data at different places, and so whereas in Terra at the moment you can only work on either in Azure or GCP in terms of where the data is stored as well as where you compute. This allows you to have your data coming from different places and then also to choose where you want to compute after that. So my question is for people who have image data, so you say you can have files and you can have tables. If you have image data, is it better for them to process that image data offline and brought in sort of the processed data as a table? Or what happens if they have kind of proprietary image software? Could that be something that could be added to the workbench?
Yeah, so both are feasible, and it would depend on what you'd like to do downstream. For our without knowing more details, we would recommend a pre-processing step so that the data are more easily comparable. So in the genomics space, we are running this in HiFi Solves. We are running the same secondary analysis pipeline across all 10 and eventually 30 nodes to make sure that the data are then cross-comparable. So I'm not sure if that's analogous to what you're suggesting here, but in other spaces, we try to drive consensus around how the data are pre-processed just so that it's easier to compare downstream.
Yeah. And then I was interested in the AI, the flower. That sounds amazing. So can you provide a bit more detail about what's in there?
Yeah, so Flower is a toolkit that allows you to train machine learning models across networks where the training routines happen at the nodes and the model weights are communicated back to the central controller and then aggregated to build a ultimately more accurate and stronger model. And so you could look at their documentation. They have a long kind of library of the kinds of models, whether it's CNNs or support vector machines that can be trained in this way. And that framework rides right on top of the GA4GH footprint that we already have. And so we're using Flower to train sort of predictive classifiers for medication use, for example, across pediatric hospitals, where none of the hospitals actually have to share any of the training data, but we can ultimately build a better model. So I'd recommend, if you're interested in training that kind of ML model, if you look at their documentation, they have sort of great getting started guides. If you could frame your training experiment following Flower, we can sit it on top of the platform.
Okay, that sounds great, because there are use cases in the consortium where you've got health data sitting in very different places that can't move. It's good to know that's feasible. Thanks.
Go ahead, English.
Yeah, one more question. So I know this you are sort of releasing as open source, and have you worked on in collaboration with the other researcher? So if I have a novel idea, and is that possibility to work with you guys to bring in some or build some new software? Have you done those kind of projects?
Oh yeah, so I should clarify the standards that we implement are all open and the architecture is all open, following that national blueprint. Our implementation of those standards right now is closed source, but that's not to say that we don't strongly encourage collaboration and extension of the platform by virtue of all of the APIs that we expose being open standards. That creates the sort of open innovation ecosystem where you can take and extend the platform in many different ways. So I'd love to talk to you about what in particular you'd love to add, whether it's a new visualization or a new, flower-based machine learning model or a new secondary analysis pipeline. Each of those has their own kind of launching off points, but we've been really thoughtful and really encourage those kinds of extensions.
Sure. Yeah, I don't want to discuss those ideas in public, but happy to connect offline with you.
Please do. Yeah, please do. Yeah, we'd love to. And going back to licensing to sort of connect Nikki's comments and your earlier's, we, in the context of Hi-Fi Solves, we just have a relationship with PacBio, who's subsidizing the costs across all of their customers currently. And so I think that's probably a better model where we discuss sort of a network license agreement, and then anyone in your network can have access to the software for free.
Perfect. Any more questions, comments for Mark?
Yeah, I
Amos?
have one question.
Oh,
Hi.
So-
Francis first and then Amos. Go ahead.
Yeah, sorry, I didn't raise up there. But I'm following up on Nikki's question with regards to the image data. So does the platform also support climate data, not only genomics data?
Yes, yeah. It's pretty agnostic. The simplest way to describe it is as long as you could represent your data as a file in one of those object stores or as a table in one of those database connectors, then we support it. Yeah.
Amos?
Hi, I think it was a good presentation, and I must admit I've missed part of it. So my question is, in terms of the federated architecture for what you've done on the platform, what can I benefit if I put my data there, or maybe I've built model on that system? What can I really benefit in terms of maybe testing with other people's data? How is that relationship coming into play? And I also believe that this video is going to be shared at the end of it all.
Yeah. Well, there's say two main benefits. I think as a single organization, the benefits are that you are operating on top of sort of a standards compliant infrastructure, and you don't have to reinvent the wheel on how to do, say, secondary analysis or data sharing or data governance. Like all of that is out of the box and in compliance with industry standards. And then that alone, I think, is valuable, but even more so, it creates the opportunity for you to now collaborate with other organizations who've connected on top of the same system. And that's where we see the network effect opportunity, where I showed the example of a federated allele frequency, right? So we can more dynamically and more accurately compute a global allele frequency by virtue of the fact that we're now reaching across more data sets. And some of our collaborators, for example, are using this as an opportunity to train better classifiers. So we talked about the flower toolkit as a means to, let's say in a diagnostic scenario, train a better diagnostic algorithm. And so we have some of our partners, both in oncology and in methylation analysis, who who are training better diagnostic applications because they now have access to larger and more diverse data sets. So just to summarize, there's value in not reinventing the wheel and having a standards compliant platform as a single organization, but then it creates that opportunity to drive collaborative insights that are more powerful by operating in a network. Did that answer your question?
Yes, it does. I think partly. What I wanted to have maybe in this conversation was, let's say I'm bringing in my data, okay? I'll give you an example. For example, if you're working with Mayo infrastructure, the Epic, so they have an federated analytics system. If you come in with your data, there are industry standards or organizations that have already done model across various data sets from various regions, okay? And they probably want to do a cross study on your data. What is value addition in terms of me having my data there and someone else, or maybe will probably want to use it just to visit it and maybe test his model on? What are the value addition on that?
If I understand the question correctly, you're asking as a data custodian where someone wants to analyze my data, what is the benefit to me as a custodian or owner of that data?
Yes.
Yeah. So what we're typically seeing, and like we've talked to some pharma companies who are experiencing this already, where the traditional model has been, okay, we'll subsidize the cost of your sequencing if you can then take that sequencing data and upload it to AWS in the US. And I know a lot of countries and organizations are starting to push back on that model. So as a data custodian, what this provides as a benefit compared to that scenario I talked about was sovereignty and control over who has access to ask what questions of your data. So you are at all times have physical and administrative control over the data set that you're connecting to the network and controlling who has access to ask what kinds of questions. Does that make sense?
Yeah, yes, it makes sense. So these are final ones. Sorry for dominating. So on the workbench, let's say I've linked the workbench to my infrastructure, maybe GCP or AWS or Azure.
Yes.
Does the cost of what I've paid for the platform cut in for what I'm going to pay in the cloud? Because if I'm running it on my own environment, that means there is a compute below it, right? It's running on top of compute. So who is covering this cost? Is it me on my subscription, or maybe now the cloud cost comes in differently?
Yeah, good questions. We're very flexible here. So I showed you the allele frequency question. Typically, the allele frequency question, because it's just an SQL query across, say, a Postgres database, the cost is actually relatively low. So many of our data custodians are willing to offer that question and actually just pay the bill. There's another option where if you want to enable someone to run a federated learning experiment where that's actually more costly compute, then we have the ability for them to set up an engine in their own subscription, but still local to the data that where it would be pay your own consumption bill. And so in that model, we would be able to bill back whoever's asking the question. Essentially, we'd love to understand like who you'd want to pay under what circumstances, and then we could deploy the technology in a way that aligns with your billing requirements. Indresh?
I think that's an old hand.
Oh, okay.
You do have a question in the chat. Can you see it? Can you read it?
It says, does the platform support relating or managing multimodal data of a single instance in health sector, like a patient, to create a comprehensive data set? So I think I understand this as like, can you bring together multiple data types like medical record data and imaging and genomics on a single patient to create sort of a comprehensive view? If I understood that correctly, then the answer is yes. Yeah. So we are quite frequently bringing together multiple modes of data. In the context of Hi-Fi Solves, for example, we're bringing together genomics, clinical notes, and phenotype, and we're creating a tertiary analysis pipeline that takes into account all those data types to deliver an answer. That's one example. Thanks for the question.
Any other questions, comments? All right. Thank you so much, Mark. I think it was very helpful. From my perspective, I'm part of the Inform Africa Hub, and we do have data from different type of data, but mostly from government, which is not, they're not comfortable sharing outside our hub. And I do believe that they will be a little more open to sharing it as an aggregate, as like with your question modality. I think that would be very interesting to look into. So we hope we can talk more about this with Elwasi later on. So well, thank you so much for joining. Francis, we will be sharing the recording, right?
Yes, we will.
Perfect. Any other business, Francis?
Nothing from my side, just that yeah, our next meeting will be in February, and I think we will communicate during the planning meeting. But then, should there be any follow-up discussion with regards to the presentation from Mark, I think we can share your email so individuals can reach out to you. All right, sure. Thanks.
Quick question, Mark, do you mind sharing your slides?
Yeah, no problem. Absolutely.
Perfect, thank you. And Taku, I see your hand raised. Is something to bring up? Taku?
Oh, sorry. I think that might have happened by accident. Yeah, but thank you.
No problem. No problem. All right, thank you, everyone. Have a good afternoon.
Yeah,
Thanks, everyone.
Thank
Bye.
you.
Thank you. Cheers.